Hello, Flat Earth researchers, debaters and debunkers. Let's have a look at this argument between globe Earth defenders and flat earthers about the horizon always rising to eye level, which is the focus of this blog post, Flat Earth Insanity. So in this video, I want to do that, address the photographs and the videos that are featured on this website, so we'll have a look at those in a second. But where I'm going with this is to, let's bring that up, talk about why the horizon is so integral to the globe model argument, and then discuss a bit about how the human eye perspective creates a horizon. It's not necessarily due to the Earth's geographical form. And then I'm going to look at the claims of horizon dip being some kind of evidence that we have this drop of the horizon at high altitude. But we're going to have a look at some low altitude examples of what is being seen when it's not actually a dip. And a final message will be to not take this personally. If you are a globe Earth defender and you have made certain claims or you have certain beliefs about the way things are, this is never intended to be a personal attack on anyone. Sometimes I use examples from globe Earth proponents that they've put on their YouTube channel or their website or whatever, and hopefully these are, it comes across as being constructively criticized, and these aren't personal attacks. But of course, if a personal attack comes my way, then I will defend that, and I'll try to do it as in a kind of as much of a positive way as I can. But sometimes the attacks on the personality or the assumptions about intelligence and other things like that are very bigoted, rather than being in any way constructive. So it's always been my aim to share what I've seen and experienced and tested, as well as many other people, and collectively we hopefully build a better picture of what we're really seeing or what we're really experiencing. There's no harm in questioning what we are told to believe, and if anyone takes it personally, then really what that what that means is that you are defending a belief. And so my mission, as it were, has always been to just encourage people to get to that point where they don't shy away from really questioning the things we think we know, and then discerning the difference between knowledge and belief. And at the same time, this is part of a journey to try and detach from this materialistic view of the world that we have and our attachment to it. So that said, that's kind of the last thing on the list, but it's also very important. Let's go and have a look at what is being said in this blog post and address what we see. So why is the horizon so integral to the globe Earth argument? Well, it's of course because the globe is supposed to be a sphere with a fixed geometry that has been determined already through various experiments, such as sticking sticks in the ground and measuring the shadows and making assumptions about the diameter of our Earth. So in that sense, we have something that's supposed to be very fixed, very precise distances across and around the circumference of the Earth have been determined already. Of course, circumference can just refer to a circle. So, for example, Eratosthenes' interpretation of the measurements he made with the shadows is just that. It's an interpretation of the circumference that the sun orbit does above a level Earth. That's another interpretation of that you can make. So from the very beginning of this assumption that we live on a globe comes an assumption, not a measurement, but yes, some measurements maybe, or calculations of shadows and those angles and those angles have been converted into a spherical Earth with a fixed diameter or radius, wherever you want to try and make calculations for the distances and the angles of the Earth that we live on. So with a geometric horizon, obviously if it was all down to observations, then we would observe a horizon that drops away from us. And again, there's no denying that the mathematics for this particular model works very well in the model. You can calculate everything down to multiple decimal places if you like, and it will be very accurate for the model. And in certain respects, you can assume that that's what we see happening when we are on or above the Earth. However, reality, what we actually observe, doesn't fit with how it's supposed to be when we make observations on or above a globe, according to their model. So the whole entire model is dependent on this, on being able to make these calculations with Pythagoras' theorem about the height of an observer above the Earth and the angle at which they would look down to a horizon. So that's why we also have an argument about the horizon dip. We should see this dip as we look down to a horizon. So, of course, this is why the eye-level horizon argument is such a contentious one. It's the difference between a model and what we observe in reality, and understanding that we've been taught to interpret what we see as evidence that we live on a globe, rather than seeing it for what it really is, or understanding that when we make an observation, any observation is governed by perspective. So let's look at the argument that we have here with a high altitude shot using a theodolite app in a phone, I think an iPhone. So the app tells you when you're looking level, and this does seem to be an eye level shot where the view out of the window is totally horizontal. And what the author has done here is shown that there's a gap between the center or eye level of the field of view and the horizon line that we see down here. So this comes on to understanding really what we see and how perspective affects what we see. When we are high above the surface then of the Earth, the cloud layer becomes the surface that we see in our eyes. So it's just a natural phenomenon of the way our eyes work in order to perceive distance, is that everything in the distance above us goes down towards the horizon, and everything below us going off into the distance appears to rise to our horizon, because the horizon in our eyes is a personal thing. It is subjective, not objective, which is the way it is put across with a globe model. This is a very important aspect to understand, is that horizons are created in our eyes, because that gives us the perception of distance, perspective. The further away something is, if it's above you, then it will appear to go down towards your personal horizon as it gets further away. And the same is true for something beneath us. As that goes off into the distance, it will appear to rise to our horizon. It just so happens that most of the time when we look at the horizon, it's across a level Earth in which we see a flat horizon all around us, and it does appear at eye level, regardless of the size of the Earth that you assume is beneath our feet. That's how our eyes work. However, what's happening with these high altitude shots, and we can see here that the author has lined up the theodolite app in the, or lined up the telephone with the theodolite app showing that he's looking straight ahead at eye level. And then we see what appears to be a horizon line below eye level. And so this is claimed to be a dip in the horizon, some kind of evidence of geometric curvature rather than the horizon being an optical phenomenon created in our own eyes. But what do we see here? We see the land down here, and then we see a cloud layer that becomes increasingly thick over distance and becomes very blurry. So what we have to understand is, because the way perspective works is that the clouds beneath us, or indeed coming up to the same height as us at this high altitude, become the surface in our vision. It's not the surface of the Earth anymore, it's the cloud layer above the Earth that becomes the surface that we see in our field of view. And it's that surface rising up to eye level. So although we can't see the surface of the Earth extending off into the distance because of this cloud cover, that cloud cover is below us, and so it becomes the surface in our vision. So we do have a very distinct horizon line here where the sky above us comes down to eye level, and the surface of the Earth and the cloud layer below us rise up to eye level. So this has been mistaken here as a dip, whereas we're actually seeing exactly the same phenomenon as we do at a low level, with the horizon being in the center of our field of view when we look straight ahead, and then the surface being whatever's beneath us. If it's clouds, they come up to eye level. All right. So there's a couple of videos here, and this one is by Wolfie6020, talking about the relationship between the horizon that we see outside and the heads-up display with a horizon line on it. And we'll have a look at this one as well. Now, again, before going ahead, I want to go back to that "don't take it personally" point I made. My interactions with Wolfie have been both positive and negative, and most recently he was very helpful in helping me get back to my wife and kids in Thailand, and I very much appreciate that. And as I said before, my interactions have never intended to be personal attacks. However, there are a group of supporters of Wolfie that do like to make personal attacks, and they might see it as banter, but to me what that really shows is a bias and to be honest, a lot of bigotry there, which comes across when making claims about one's intelligence just for simply questioning and pointing things out. So, as I said, don't take this personally. It's great that there's someone out there who's flying aircraft and can show us examples of what we see. And all I want to point out here is that, as I pointed out with the image above, is that we do have a horizon at the observer's eye level, and we also do have a horizon line in the heads-up display at that same level as the horizon. So what Wolfie appears to be pointing out here with his finger is that when we see the horizon line on the heads-up display, it is up here, and that is higher than this line we see here, which, as I said earlier, is where we start to see more cloud that's below us, and the cloud is rising up to eye level. So as far as I'm concerned, while we're not seeing the physical hard line of a horizon on the surface of the Earth, because it's being obscured by these clouds above it, yet below us, we still have the surface of our personal field of view beneath us appearing to rise up to our eye level, looking straight ahead. And that is, I think you'll agree, in line with this the heads-up display horizon line. Let's just have a quick look at that and you'll see what I mean. Okay, and he then goes on to show the view through the infrared camera on the front of the aircraft that is giving this superimposed view of the surface and a much clearer horizon that does in fact appear to be below the aircraft's horizon line. So he is flying straight and level, and we can see that he's on target with the flight level indicator here, and so this would tell us that he's flying straight and level. Although an aircraft, the aircraft that he was flying, has to pitch up as it's flying straight and level at this high altitude in order to maintain that horizontal level flight. So bearing in mind that the infrared camera is on the nose of the aircraft and that the nose of the aircraft is pointing higher than the actual aircraft's center line or level here, then this will give us a slightly elevated view or an elevated angle of view for the infrared image that's been superimposed on the heads-up display, along with the projection of the other indicators. So that's one reason, but the other is I'm not sure about the actual science of infrared. Okay, it can make you see further, you can cut through certain cloud density, but of course it is also going to have a limit, just like a radar has a limit. So the horizon line here, or another contributing factor to seeing a lower horizon line than is indicated on the heads-up display in this night vision infrared view, is because you don't know how much information is coming back to the camera from the infrared light that it's putting out there. So it's just another factor, but in our normal vision, we do see the horizon at our eye level, because the horizon is the place where everything appears to converge in our field of view. And we can see again the same thing here with this one. Yeah, we've got the cloud layer below us rising up to our horizontal eye level. But of course the claim is that there where the cloud starts is the horizon. Yeah, it's quite simple, and so to point this out isn't a personal attack. I'm not assuming that deceptive techniques are being used. I'm pointing out what these people might be missing in making sense of their observations and the conclusions that they draw from them. So the conclusion here, of course, is drawn that the flat Earth is flat out busted because of this apparent horizon drop. So let's go and have a look at that dip. And before we do so, there's this random photo that I found on the web. I think it's a real photograph, but it's looking through the heads-up display on an aircraft, and we can see here that it's at 37,000 feet, so it's quite high above the Earth, and we do indeed have a horizon at the same level as the horizon line. So it does seem to happen in other cases that the horizon line on a heads-up display is in line with the horizon in the distance at a great altitude, and so we are not always seeing a dip, and when we do, it's possibly a misinterpretation of what we're seeing. So let's go and have a look at that now. I've got some other photographs lined up. So again, this is one of those memes with the argument, and we see that this is being referred to as a dip because this area of cloud that is actually lower than the aircraft, comprising the surface, is considered as being below eye level. Well, it should be. It's fine. That's how it works. It's below us and it is rising up to eye level. So again, this is a case of mistaken identity on part of the globe Earth proponents. Let's now have a look at, we're going to have a look at some ships in a minute, but first of all, let's have a look at one example of this theodolite app looking at a horizon from a low level, low altitude, and we can see here that the crosshair is again higher. But of course, we can also see that there is quite low cloud cover here. It appears to be very misty, and so it's really not very conclusive in that respect. But this isn't a very great height, but we have this claim of a massive dip equal to the dips that we are supposed to see from much higher altitudes. It's 371 feet. So you can kind of really knock that one on the head because of the visibility. And visibility really is the issue here. So let's have a look at some photographs that could be passed off as mirages, but what it shows us is what we are not seeing when we assume a horizon dip. So we see this boat here that appears to be floating above the surface. We can see this horizon line here, and we don't see the surface extending up to or even beyond the boat that is in fact still sitting on the water. But what we can notice is that the sky above is a very uniform, hazy, kind of blue-grey colour. And so in fact what we are seeing here on the surface beyond this horizon line is mirroring. And where we see mirroring does in fact relate quite well to the geometry of that's used for the globe to say how far away the horizon should appear when we're looking across a surface from the surface of the Earth from a particular height. For example, if we're 2 meters high, then we can maybe see about, I think it's about 5 miles or 5 kilometers, 3 miles. I can't remember the exact number. And that would appear to be true when we see this kind of hard edge of a horizon line on the surface when we're at a low level. And then this boat appearing to be floating would be considered or passed off as a mirage. But no, what's happening is we have a mirroring of the sky above. And yes, a horizon line that if we got higher up, then this horizon line here would appear to extend. And eventually we'd get high enough that we would see the color of the water, the same color of the water, nearer and beyond the boat. So what we can do is have a look at some other images that show that, and we can see it a bit more clearly. So if we do, you can make out here the actual horizon of the water. But of course, what's happening at this distance across the surface is it's reflecting the sky above. And yes, we have some clouds, but again, it's a very uniform color. The quality of the photo isn't that great, so a lot of detail will be missing there, but we really can see that there is a horizon there. So this kind of apparent horizon line would be passed off as dip when we don't see a massive contrast between the rest of the surface going up to eye level, or the horizon, and the clouds above. What I've done here is just put a line there to show where the actual horizon is, and how we have this what appears to be transparent because it's the same color as the sky surface. Yeah. Let's have a look at another one. This one's quite intriguing and demonstrates this quite well too, because we obviously have ships and boats at different distances. Yes, they're different sizes, but we can see that this one is much closer than that one. So we have, you can see some reflection of the clouds above in the surface here. And so if I've tried to put a line there, because we have this distant boat that would be on the horizon, this one much closer, so the horizon would be behind that boat, and again this one is maybe even closer, and so it's in front of the horizon more so. But again, we can see this reflection or mirroring. It's not a mirage, it's just mirroring because of our angle of elevation. It's a decreasing angle of incidence of the light reflected to our eyes. So what we get is the reflection of the sky that's coming off the water, as rather than the water itself being reflected into our eyes. Remember, if it's not a light source, then everything we see is light being reflected off it. Light is reflected off the boats and reaches our eyes. Light is reflected off those clouds and it reaches our eyes. And the same, similarly, light is reflected off the water. But as we look across that water at a relatively low level, that angle of incidence of the reflective light becomes so compressed that we can't make out any detail on the surface anymore. Again, this is because horizons are subjective, not objective. Here's another example, and this is, it looks very extreme at first, but again, in all of these cases, we have a sky that is a grey, or it's a very kind of washed out color. It's hazy, so it's creating a mirroring of that sky, and so we don't see any discernment between the actual horizon. And again, we have an apparent horizon here. I think I put a line here. Let's try. Yep. Okay, so the horizon could be well beyond the boat, but it appears to be floating just because of our low elevation and the mirroring that we're getting from the surface, reflecting the sky above it. Okay, and another one. Again, this is. I think we've looked at this one. Yes, it's a little clearer, a little better defined. Okay, so this is why we do in fact see a horizon at eye level. This is why they have mistakenly identified pictures like this as being a horizon that dips below eye level. It's all down to visibility. Yeah. So that about that wraps that up, and I welcome attempts to disprove this, but unfortunately, even when people attempt to do it, they seem to interpret it in a way that would favor their belief rather than admitting what they're actually seeing. Thank you very much.
Click subscribe and the bell icon if you'd like to receive notifications of new videos from Phuket Word.